Hello, and welcome to Procedural Programming with JavaScript. So procedural programming honestly isn't that different or unfamiliar to us. We've been doing some of this stuff the whole run. We're really just adding a couple things into the toolbox and being a little bit more deliberate about how we process logic top-down. So before I dig in, hit me with some questions. What has been difficult about procedural programming so far?
Well, first off, you're sharing a very large screen here, more than just you. Yeah.
Oh, it's the wrong one. Oh, it's because I plugged my monitors in the wrong order. That'll do it. All right.
I'm kind of curious about like real world practical examples. Like, is this the kind of thing? Can you use this in conjunction with APIs and stuff like that?
Yep, you absolutely can. In fact, I'd say procedural programming is probably by volume most of the code in the world. So like paradigm-wise, it fits in like this. These are our three dominant paradigms: functional, object-oriented, and procedural. Hang on just a second. Elise? Hi. Hello, how's it going? Pretty good.
Good, nice seeing you again.
Yeah.
Right.
Just want to take a look at the AC?
Yeah, so that's what we're doing today, right? Doing the service to the AC?
Yeah, I think so.
Okay. I parked behind your garage. I can knock on the door. Is that okay?
Yeah, totally fine.
Awesome. So yeah, I'll get to know. It's not taking too long.
All right, awesome. Thank you.
Any questions for me? Any concerns?
Nope. Thank you. Sorry about that. I have the AC repair guy here. Okay, so there are three paradigms: functional, object-oriented, procedural. So with functional, we're talking about prioritizing peer functions, describing things as transformations, being trying to avoid state. So state is like variables. If something can be on or off, that's stateful. Functional stuff, think like map, filter, reduce, those kinds of things. There's usually not much state in those. And when there is state, like we're saving something in a variable, like making a DOM element or something, that state is super short-lived. And it turns out state is probably the source of 90% of bugs or stuff that makes code hard to work with is weird problems with state. And so functional programming's approach to this minimizes that. And so functional code tends to be more correct. Object-oriented code is usually modeling the real world. It's containers of state. That's what an object is. Sending each other messages to change state. Um, so if this is about transformations, this is really more about modeling. And functional programmers are like pathologically afraid of state. Object-oriented programmers love state. Everything is stateful in OOP. And so we haven't done any object-oriented programming in this program yet. We will at the beginning of the Angular stuff, and Java is a pure OO language. You really can't do anything that isn't object-oriented in Java. And then procedural is what I would say undisciplined about state. It is telling the computer what to do. It's very literal. So in both of these approaches, you're usually saying like what you want, or you're creating some kind of model of how things interact with each other. Procedural programming, you're usually saying, computer, I want you to read this, I want you to write this, I want you to do this in this order. So you're not really modeling the real world. You're not writing pure functions. You're just telling the computer how it should solve a problem. And with both of these approaches, we're usually deferring to the computer. You're saying, hey, I want this. You figure out how it gets done. At some level, all code eventually needs to be procedural because somebody needs to tell the computer what to do. But these two paradigms help abstract that out a few layers to make that kind of not our problem. But procedural programming is super fundamental. And like in terms of where these three paradigms shine, functional programming, transformations. If you have to turn data from one format to another, functional is your way to go. Object-oriented, very good at modeling real-world problems. So like teachers and students and classes and grades and like that sort of stuff. Procedural programming, really good for simple stuff. Simple problems are actually pretty difficult to do in these paradigms most of the time. Procedural programs, not so much. And so if you're wondering, hey, can I bounce back and forth between these three paradigms in the same project? You're goddamn right you can. That's actually pretty common, and I think it's one of the advantages of JavaScript, is that JavaScript is very good at letting you do all three of these things just effortlessly between them. Where there's languages like C only does procedural programming. Go only does procedural programming. Java only does object-oriented programming. Ruby is only object-oriented. There's a little bit of procedural. And then Clojure, Haskell, those are purely functional languages. You can't do object-oriented or procedural stuff in those. So that's like a quick overview of these three ideas. So real-world examples, they're all over the place. It's probably like 3 to 1 more common to see a procedural program than a functional or an object-oriented one.
It seems like most procedural programming that kind of we've seen is based around arrays. At least a lot of it seems to be array-based. Is that typically the case?
Honestly, you probably see it more with functional programming. Those chains where we like map and then filter and then map again and then reduce, that's like functional programming in a nutshell. Doing that exact same thing procedurally would be looping. For loops, while loops, all of those kinds of things, that's procedural. And so I don't know that like arrays have a bigger role in one or the other. It's more that like arrays are a really critical part of how we iterate. And iteration is one of three things that like kind of make up programming: sequence, selection, and iteration. And so you tend to see arrays on anything that involves iteration, and iteration is everywhere. So that might be one of the reasons you're seeing it a lot.
Yeah, I guess that's what it was. Just looking at like all the while and for loop examples that we have, they're pretty much all centered around arrays and doing something to an array.
Yes, and that's really like that's data transformations in a nutshell. So some other things that like are giveaways for these styles. So this is .map, .filter, these then catch. Like all of that stuff is like pretty good sign that you're working in a functional paradigm. Object-oriented, the word new, the word this, classes, and spoiler alert, objects. That stuff is giveaways for object-oriented stuff. Procedural, while, for. Yeah, come on, yep. There we go. If, switch. All of those are like giveaways that you're doing some procedural programming. More questions about procedural programming thus far?
Or when we're talking about fetch requests and things like that, would that fall under it?
So like things like fetch requests can go a few different ways. If you do a fetch request with then catch, you're doing it in a functional style. If you do a fetch request with async await, you're doing it in a procedural style. More questions? Something that's fairly core to procedural programming that I think students struggle with a lot is the idea of counters. So if I have an array and I want to iterate over that, bunch of different ways I could do it. So I could do like some array for each. And then do something with it. That's the functional way to do that. The procedural way to do it would be like a current index initializes to 0, and while the current index is less than some array dot length, console log some array at current index, and then increment the index. That is like bread and butter procedural code. So functional style, procedural style. And hopefully it's clear why this is way more like telling the computer what it should be doing. Save this value, test this condition, do this thing, change this value. None of that stuff is happening here. I'm saying what I want, and then how it loops through that array, that's the computer's problem. So some other words you'll come across for these are declarative, declaring what you want, imperative, telling the computer what to do. Some things that procedural programs are also really good for, and this is the case with like a lot of the kinds of goofy problems that you end up doing in interviews and stuff are like, all right, well, get every third item in the array. Okay, that's actually kind of hard to do with this because we need to take the index. Actually, a better way to do it would be to filter out everything except the third item. So like you take in the item and the index and return index modulo 3 is 0. So that'll give you like every third item on there and log it. That would be the functional way to do that. The procedural way to do it would be like, done. So a lot of those kinds of like abstract torture problems, I think are a little bit easier to do imperative. Hi kids, welcome home. Questions?
I know you hate single letter variables.
Yep.
I see it used a lot, obviously, in procedural.
Yep.
Is that something you prefer to be writing like current index equals, or does it not really matter when we're working with this kind of stuff?
Like, I'm going to say this is a house rule. As long as you're under my roof, we write descriptive words. Because, yeah, what you'll see almost everywhere else is that. And then this will be something like that. Okay, I don't know about you. I think that sucks to read. That's way more complicated. Let's see. What was it before? Okay, so we had that. Okay, that's the way you'll see that written most of the time. I think that reads a lot better. I think this puts a huge cognitive load on the reader to translate all of those short variable names into what they actually are. And so inevitably, when somebody starts writing this way, they do shit like, okay, but like, why couldn't you have just named the variable that? Or another one I'll see a lot is people will do like that, and then they'll get them mixed up. So they'll go like, hey, why isn't that working? Oh, because it wasn't ITM, it was actually I. And so I think you save yourself from a lot of hours of debugging shit like that if you write out the whole word. Or man, the number of times I've screwed up and seen other people screw up nested for loops. So the way that those tend to work is you write a for loop. I guess it would be R. So you do something like that, and then the array has something else inside it. So it'd be like maybe these are all objects, and it's Kyle, and so if I want to write all the, print out all the instruments, well, I have an array of objects, and inside of that is an array of instruments. So the procedural way to like loop through those would be to have one of those, and then make a for loop inside of it that does like let j equal 0. Then let's really go all in. That one's going to be that. It's going to be that. This will be JLN equals R2 at I dot instruments dot length. And while j is less than j length, increment j. And then you want to log like R2 at I at j. Okay, so that's how you do like nested loops. The likelihood that you are going to screw up that j and accidentally do something like that or something like that, or compare it to the wrong length like that, there's just so many ways you can get that wrong. And since you just put random characters on the screen, that makes it extra difficult to debug. Now, by comparison, if I write this out longhand, person index person people count call that people. So, way more verbose, way easier to debug, way lower likelihood that I'm going to screw something up. And even like these long line lengths and stuff, I can break those up. That's fine. I feel way more confident that I'm not going to screw that up than this like math equation shit. And when I'm looking at this a month later, 3 months later, a year later, when somebody who isn't me is looking at this and has their own stupid abbreviations that they use for this stuff, like, this explains my intention. This this is all of the context that you need to understand what's happening in this. A lot better IMO. Questions?
Not a question, but having just spent like an hour and a half looking at that selection sort algorithm.
Oh yeah?
Wiki that you sent us.
Yeah.
Would have been a lot easier if they actually.
Right? Explain.
I was thinking the same exact thing.
And so, okay, so real talk. Let's take a look at it. One of the things that I do, let's see, is there a good one here? So let's say I take one, or we can do the Wikipedia one because I think that's what I like to. Okay, so we've got this stupidly written thing in C here. Okay, so one of the things that if somebody sends me this, or this is the only reference I have to some algorithm, take some time and rewrite it less stupid. So, like function, selection, sort. Okay, I and J. So looking through these, what are I and J? Well, they're not initialized to anything. I don't know what they are yet. So we can say like let outer index, let inner index. Because I see it used there and there. All right, fine. So that's that. Initialize to A's length. A is the array. So this like takes in some array, like let array length, array dot length. Cool, cool, cool. So we've done all of those. Advance the position through the entire array. So if I'm writing that, this was the outer index, this was array length, this was outer index, this is outer index. So not that anymore. So before we do this inner loop, we declare a variable j min. So that's gonna, so j is that inner thing. So we could say like, let inner minimum equal outer index. And then we loop again. So that's j is the inner index, I is the outer index, plus 1, because it doesn't need to compare to itself. J is the outer index. The array length is that. This is, and then we increment the outer index. Already, it's like a little bit more clear what's happening. We loop through the entire thing, and for each item in the array, starting with the one after it, so if the outer index is the first item in the array, this is going to be the second item in the array. And then otherwise, we still go through the entire array. And we have that inner minimum there. Then there's this if statement in here. So if A, which was the array, at J, which is the inner index, is less than the array at the inner minimum. But it's not the actual minimum. It'd be inner minimum index. So the array at the inner minimum index, then that means that we found a new minimum, so that the inner minimum index is whatever the inner index is. Okay, so now we've done all of that. That was that. And then that was all of that. And so then this last part was if jmin, which was inner minimum index, does not equal the outer index, then swap array, outer index, and inner minimum index. And so swapping, and that's the whole algorithm. So swapping is take the thing from wherever it is now, like just flip those around in the array. So since we don't have a swap function, it would be something like let temporary placeholder equal array at outer index, and then array at outer index should be equal to, so we're going to set it to array at inner minimum index, and then we are going to set array at inner minimum index to temporary placeholder. Cool, and that's selection sort. So it's still complicated, but that and like we don't even need some of this stuff. We can initialize that out there, so that's not needed. We can initialize that in there, so that's not needed. Right? Yeah, that's all happening in there. And then this array length, this can just be array.length. So we can simplify the thing we were looking at a little bit. Okay, that's like a little bit more clear. Clean up some of the code. So we loop through the outer thing. We set the minimum index to right where we are. We loop through everything else in the array. We compare it from what we are now, each thing after that, to whatever the minimum that we found was. If we find one that's less, then we set the index to that. And after it's looped through everything, if the lowest one isn't the one that we're on, then we flip them around. Ta-da! Selection sort. So that versus this shit. And hey, weird, look at all these comments they put in there to help us. And look how unhelpful they actually were. That's why I'm so anti-comment. Frankly, like, even this stuff is easier if you get rid of the comments.
Yeah, I don't think I really looked at any of those comments when I was looking at the actual algorithm.
No, they're unhelpful. Okay, so that was the original code with its very terse variable names. But that doesn't need comments. That's what we call self-documenting code. Way better.
And the entire function for selection sort, you are using procedural programming for that one?
All of this is procedural programming. This is procedural programming to death. And like, this would be useless to do in an object-oriented or functional style. Implementing an algorithm, procedural all the time. Ugh, implementing that with functional programming would be a nightmare. By the way, this algorithm, that's how you, like, if you're just holding like a deck of cards or something like that, and you're like, sort it. This is what you do. It's like the most natural, intuitive way to sort something. That's what it looks like in code. All right, other questions about procedural programming? Going once, going twice. I hope that helps. Cheers.